Okay, guys, I want to share with you the revision that I'm going to do of the optimization model I have developed. Okay, here I have a lot of data model generated network. So okay, in this project in RFEP network, I have defined the it's where my model is. So here I have, what do I have here? Have a network.mod file, have a RFEP network.dat file. This is a configuration file of the model. Let me check what is in this configuration file. In this configuration file, what I have defined is that, okay, is that I'm going to export the LP format of the model. Yes, which the LP format of the model is a file of this style, in which I can see which are the generated equations, which are each generated equations. Well, oh, this seems to be the objective function, isn't it? Yes, total cost. Beautiful. Wow. So finally, the model. What is this? Okay, so finally, yes, the model have 3,590 lines. Okay, that's quite interesting. And so, okay, let's revise the model. I have a problem. Okay, so this is the LP file, but first let me show you who is the magician. This is the guy who makes the magic for everything. So let me revise. So first, in this part of the document, I define a type of tuple, and this type of tuple is important because I'm going to assign this type of tuple to store certain type of sets. So sets that have sets that are made out of two sets. Yes, and this type of sets I'm gonna call tuple sets. Sets that are made out of three sets. Yes, and sets that are made out of four sets. Yes. So, but first of all, let me make sure I'm going to have, this has been the file that I have been revising. So I'm going to copy this in here. And then I'm going to bring this file here. And I'm going to call it, I'm going to rename it, and this is going to be the 7th one. Yes, and since I rename it, this I need to, in the .dat file, I need to say that I'm working with this file. I'm going to be working with this file, okay? So in the model, what do we have? So the first part of the model, all of this is about reading data. Yes, and to read data, the first thing that I need to do is that let's have a look to that file. Let's have a look to that file. This is wrong. Blah blah blah. This is wrong. Yes, this is wrong. Why this is wrong? I need to import not the input, but the output. This output is the one that I need to import. I need to import this one. So okay, and 7. That's cool. That's very good. So I have this file here. Okay, first thing that I need to do, let me show you the structure of this file. Oh no, it's open. Data model generated network. What I need to do with this file, there is something wrong here. Is that it's important that you do this always format tables. So format tables means that each table in this database has this format. All right. So as I have just done that, let me update that. Let me say save. Let me, you know what I'm going to do? This is trash. Let me just delete all of this. Okay. I just want to, I'm going to make something. Data model generated network. Here, let me put just this the /8. Wait, because I don't want to get confused if I put 1, 2 or something. I don't know what is this, so let me leave it there. So I'm gonna work with 8, then let's go again to it here. Let's write 8. We'll go to the dot file later. So here we have, okay, first thing we do, I was going to show you the file. The first thing we do is that we need to import all our tables. Yes, technically we don't need this table. I just leave this table here for reference. We don't need it. We don't need this table. No, yes, we need this table. We need this table. For example, I look, the first table I import is this substations. And I call this table substations because it's a subset of all the stations, because remember that all the stations are includes the mirror node, but the mirror nodes are calculated automatically in another procedure. And so, yeah, for example, in this one, in nodes, here is the information about the mirror stations. All right. All right. All good for now. So first thing I need to do is to define the tables that I'm going to read. Yeah, so the concept here comes like very important, the concept of tuple. So what is a tuple? You can imagine that a tuple is like a table. Yes, a tuple is like a table. In order to define a table, we need to define which are the columns of the table. So that's exactly what I am doing with this instruction. I am saying to Cplex that, hey, there is a tuple, there is a table that I'm going to call data substations that have this structure. And in fact, there could be many tables that have this structure. Yes. So I don't need to be defining each time the structure of the table. Not just I say, okay, is this structure? All good. Then when I do the following instruction, is saying, hey, I'm going to create an instance of this table. And what I mean with an instance is like, okay, you understand object-oriented programming. In object-oriented programming, you define a class and associated to an instance of a class is an object. Same concept here in tuple. Here is the structure of the table, but here I am defining, look, this is going to be the table. So each time I am referring to a table, I'm going to use the prefix info. So info substations, and this table has this type. And what does it mean this type? Has these columns. That's it. Yes. Then, what I do in the following instructions is that I read all the data that my models require from this table. Yes. So my model requires a set. Yes. And this set, if remember, how do you name a set? Yes, you say it's a set of strings. Look, this is a set of original stations that are my own station. So I'm going to say here that, look, this set is going to be equal to equal node. Yes, to equal node. And what I am doing here is that I'm saying, hey, look, all the elements of these cells is going to say to be equals to the columns, to each element of the columns of this tuple code node. Yes, but and here E is the index of the row of the table. Yes, so and I require that this E is in this table that I define here. Yes, and with one condition. Yes, that's these two dots, like columns. I don't know this column. I don't know how do you call these columns. This column represents it works like a filter or like a condition. So for each E in this table, infosubstations, such that the information in the column code supplier says, so if you remember this table, look at this table. Data facility expansion problem. Stations. Nah, it's not this one. Data model generated network. Look, substations. Look, we have a column called supplier, and we are we are doing in Cplex is saying this filter on, and all these elements are going to be part of what I'm going to call my set as original stations. Guys, there is something important to note here. The first thing, for example, the first thing I did was the model. Yes. Okay, this is not like, and it's like, hey, do this. No, it's not like a linear process. It's an iterative process, but I first do the model, and the model is going to tell me which data do I need, and it's going to be a balance. Okay, which data in real life, what you have, which data can I get, and which data can I get, so which model can I make with the data that I have. Yes, but in this case, in a theoretical way, my process was I created the model and then I created the data to supply the model. Okay, so yes, let's keep reading the inputs, and you will see as we move forward what is the logic of that input. Then I have another set that I define here. This same structure. You see here, curly brackets define the column of the tuple. Yes, of the tuple instance. Yes, define the column of the tuple instance that you want that set to be, and define the conditions for the rows. Yes, and here the conditions for the rows is original stations potential. So I want to know which are the potential stations to be built, and this information is contained in the parameter is potential. So I'm going to get all rows from this table such that the column potential is equal to 1. Okay, let's keep going. Look, I'm not gonna read the price here because for the price, I have done this trick. For the price, I have done this trick. You will see, because remember that we don't have just the stations in infosubstation. We have the stations there, but also we have the mirror nodes. And for the mirror nodes, we need also to calculate the price. So I'll show you in a second how it works. How it works that trick. So let's keep revising this. So then I have the price original. I'm not going to take care of this. Pay location cost. So I read this parameter from this table. Yes. But remember, how do I define a parameter? I define the type of parameter. Usually is a float number, is a number, a decimal number. I define in which set this parameter is read. Yes. So look, the importance here. First, you have to read the sets. Then the parameters associated to each set. So, and you can understand that parameters are attributes of a given set. Yes. So the location cost is a parameter associated only to stations that are potential. Yes, so it's associated to this set. So I'm going to say that this parameter is equal to a square brackets. Look the difference. These are curly brackets. These are square brackets. infoNode, yes, such that infoNode. So I am making reference to the domain of this parameter, like to the set. Yeah, you can understand what are you going to locate here first when you are reading a parameter, the column associated to the set of the parameter, and then you put these two dots, these columns, yes, and you define the column of the parameter, such that this parameter, such that we make the filter here, yes, that the row is in a column in which the value of the parameter or the column is potential is equal to 1. Yes, it is in this table such that this condition is met. And close square brackets. The process is the same. These are the parameters. For example, this parameter P station capacity is indexed in original station sound. So this set. So what we do is square brackets, define the set associated to the parameter, the column in the table that is associated equal node to this parameter, and we say from this table, this is the column station capacity, and so on. And here the condition is that the supplier is on supplier, so it is in the table such that the column of the table is on. So the same thing here for station unit capacity and per cost unit capacity. Same thing exactly as per station capacity. I don't want to go into the details of the reading of this parameter because it's very repetitive, the process. Then I read, look, I'm reading this table. So, okay, something important here is that instead using Cplex 3 dots, it means that this data element, this is an element of the data model, is going to be read from the data file. So you can go to see in the data file, infosubstations, and define here how I'm going to read infosubstation. I don't want into the details now, so let me just go back to the model. So I define this tuple to read this table, the table node, and this table node have two columns, which are two strings. I define the table, yes, the instance of this tuple as infoNodesNodes, yes, and the only thing I'm going to read from here is something that is called a tuple set, yes. So look, this is a set which is made of two other sets, yes. Basically, if you visualize this, will be something like this. Let me show you what is this set. This set is this one. Nodes. Look, this set is this one. So if you want to visualize these sets, it will look something like this. The elements of these sets are okay, let's do the work beautiful. So is one of the elements of this set is this element this element. Let me do this. I'm just writing here something so you can do this like in a beautiful way. You see this? You see this? Okay, good. So to summarize, what I want to show you is this. Equal to I just want to show you that it will create a set of stuff. So let me put here this. So it's equal to equal. It's very interesting when Excel gets. So it's this, and then you put a comma here. Let me see if this works. Yes. So at the end, your set will look like, look, this is the first element, this is the second element, this is the third element of the set, this is the fourth element, this is the fifth element, sixth, and so on. These are all the elements of your sets. That's what I wanted to show you. That's what this means. Yes, in Cplex, show me Cplex. Yeah, so I am defining here a tuple set that tells me what is the relationship, which tell me what is the original station associated to a mirror station. Yes, and by definition, we say that an original state, what is the original station of our original station is itself, the original station. In other words, what is the original station of value reserve station? Value reserve station. Yes, by definition, that's how we define it. But for example, what is the original station of value reserve station 1? Is value reserve station. Yes, you can see here on the relationship. Okay. All right. I have a question. In the past. Okay. I saw this. What? Okay. Anyway, we are doing well. Guys, what else? So I define this here. It's original station, mirror stations. So I define this tuple set here. So this tuple set is very straightforward to define. Again, as this is a set, I use curly brackets. And then remember how we read a set here. We have sets of one that were compound only of one set, but here we have a set that is made out of two sets or two columns. So sorry. So what we have to do, we need to use this symbol of smaller than. Okay. This open, let's call it open mouth. And how we call this? Closed mouth. So let's open the mouth, put the first column and the second column of this table. So that's going to be my set, such that each row is in this table. That's what it means. We have, okay, we have here, okay, Okay, we have another station suppliers, which is again another tuple set, which have the information of stations and suppliers. Yes. Okay, I understand. Look, this is very beautiful. What happened? For me, it's necessary to know what is the supplier associated to each station. Yes. Notice that I know what is the supplier associated to each original station, but I don't know what is the supplier of the mirror stations. But simple, that I have that information, yes, because the mirror station supplier is the same supplier of the original associated, the mirror station is associated, yes. So to calculate this set, I will have to do an operation between the tuples, yes, between tables. So this set is made out of the code node of code node 2. Yes, notice that in code node 2 are all code node 2 are all the code node 2. Let me show you code node 2. Code node 2. Yes, we are here. Look, in code node 2 there are all the stations of the model, original and mirror. Yes, and as we want to calculate what is the supplier of all the stations, so we are going to use, to refer to all the stations, we are going to use the column node 2. And we're going to use F to refer to the elements of the here of infoNodesNodes, refer to the elements of this set. So F is the index used for the elements of the table infoNodesNodes. Okay? But I want to know the supplier of each node. So I'm going to bring the information of suppliers from where? Where it comes from infosubstations. Remember that in infosubstations, I have the information. I have the information of the suppliers. Yes, if you remember here in infosubstations, in substation, I have the information for each station here. I know which is the supplier. Let's remove the filter. For all stations here, I know what is the supplier. So I have this information there. Yes, but then I don't want to bring in all the combinations of these with all the suppliers. No, because one way to do, if I do just this, saying this, I will bring the Cartesian product of all of these suppliers with all of these stations. And where are these stations? With all of these stations. But I don't want that. I want only to make the Cartesian product when this code node 2 is when this code node 1, yes, when the original node associated to this mirror node, when code node 1 is equal to code node of this table. And how do I say it? Here? Look, F code node 1 in the table nodes is equal to E code node in the table where it is, which is infosubstations. Guys, this is a little bit of the logic to read data in Cplex. Let me show you. No, I'm going to show you the calculation of this parameter, and we'll finish this video. So, look, I need to define the set of stations. Yes, the set of stations is very straightforward. Where are all the stations? In code node 2 of the table infoNodesNodes. Yeah, remember that code node 2 are original and mirror nodes combined all together. So this is the set of stations. Yes. Then, as I have the set of stations ready, I can define my parameter of price. Okay? Then the price associated to each station is equal to this. Yes. So remember, then it's a parameter, so I use square brackets. Yes. First thing I need to do is to make reference to the column where is the domain of this parameter or the set associated to this parameter. So SS stations is in F column 2. Remember that we are using the index X to refer to elements of infoNodesNodes. Looking here again, I am using that. And I'm saying here that such that as this is the domain of this set, but I'm going to take this parameter from another table. Yes, because what is the price? The price is in the table of infosubstations. So E is going to make reference to infosubstations. And then there is a condition. What is the condition? The condition is that the code node 1, so the original node associated to the mirror node, is equal to the code of the node of the associated E. Yes. Basically here, guys, we are doing joins. This is a join, exactly the same that we do in Altrix. Remember the joins in Altrix? Yes, that's what we are doing here. We are doing joins. We have information in one table, we have information in other table. We join these tables according to a given column, yes, and we are in this join, we are doing a select, and in the select we are saying, hey, I want this column of this given table. Yes, this is the same concept of a join in Altrix. So I am applying this concept here in order to bring the information of all the parameters that I have. So guys, this was a beautiful video, and I hope to see you in the next one. Stop share and stop recording.